The A330 electrical system is quite similar to electrical systems which you are already familiar with. It is simply more automatic and easier to use. There are two engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG. Each generator supplies alternating current, AC, to its own bus. Generator 1 to AC bus 1, Generator 2 to AC bus 2. Each AC bus supplies its own transformer rectifier, TR. AC bus 1 to TR1, AC bus 2 to TR2. The TR convert alternating current into direct current, DC, to supply their associated DC buses, DC1 and DC2. DC bus 1 then feeds the DC BAT bus. The DC BAT bus can charge the batteries or receive power from the batteries as required. This will be explained further in the normal operation module. The electrical system also includes two essential buses. The first one is the AC essential bus, fed by AC bus 1. The second one is the DC essential bus, fed by the AC essential bus via the essential transformer rectifier, essential TR. This is the basic electrical system. We will now introduce some other components which supply the basic system. The electrical network can also be supplied by the APU generator. These three generators are all identical, and any one of them can supply the entire aircraft electrical needs. On the ground, the aircraft can be supplied by one or two external power sources. As a backup, there is an hydraulically driven emergency electrical generator, Emer-Gen. It is powered by the green hydraulic system. The green system can be supplied by a ram air turbine, RAT, which extends in case of severe hydraulic failures. The RAT is located under the right wing. A static inverter allows part of the AC electrical network to be supplied from the main batteries, batteries 1 and 2. The APU TR is used to charge the APU battery. The APU battery is dedicated to starting the APU. Now let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electrical pages. There are two ECAM electrical pages, one for the AC distribution and one for the DC distribution. Usually, only one ECAM electrical page can be displayed at a time on the lower ECAM. For training purposes, we will show both at the same time. You can see that all the components we have talked about are displayed on the ECAM pages. Notice that each component has a title to aid identification. Let's briefly review the basic system using the ECAM electrical pages. Generator 1 and Generator 2, supplying AC bus 1 and AC bus 2. TR1 and TR2, supplying DC bus 1 and DC bus 2. Two essential buses supplied by the left side. The DC BAT bus and two batteries. The APU TR, the DC APU and the APU battery. For simplification, the component indications had been removed. Let's now present them. As shown, each component can be monitored via its indications. These indications are voltage, current or load for the generators, frequency, and IDG temperature. You can also notice the various connections represented by green lines. Let's now locate the controls available to the pilots and associate them with the components displayed on the ECAM. The electrical panel is located on the overhead panel. For emergency cases, there is an emergency electrical power panel on the left side of the overhead panel. Now let's look at the relationship between the electrical panel and the ECAM electrical pages. The battery voltage can be monitored either on the overhead panel using the battery voltage selector or the electrical DC page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch. The external power sources are also controlled by a push-button switch. We will learn how to use them in the normal operation modules. The AC Essential Feed push-button switch enables the pilots to change the feed for the AC Essential bus from AC bus 1 to AC bus 2. The bus tie push-button switch enables the pilots to isolate one side of the system from the other. You will see and do this in the abnormal operation modules. In case of failure, these push-button switches enable you to disconnect the corresponding IDG from its drive shaft. The emergency generator test switch is used by maintenance only to test the emergency generator. In this module, for presentation purposes, you have seen a ground electrical configuration. We will introduce you to the different possible configurations in the next modules. Let's assume that we are starting with a cold aircraft for the first flight of the day. When we enter the cockpit, one of the first items that we check is the battery voltages. To do this, you look at the battery voltage displayed on the electrical panel. The battery voltage selector allows each battery voltage to be checked. Let's assume that they are below the minimum required 25.5 volts. So, you will have to recharge the batteries from external power. To charge the batteries, you have to switch them on. Switch bat 1 on. Notice the off light has illuminated on bat 2 and APU bat push-button switch because now the aircraft has electrical power to provide that indication. Switch bat 2 on. OK, bat 1 and 2 are in auto position. Switch APU bat on. Because the green avail light is not lighted, meaning that you have no ground power, you have to ask the ground personnel to connect a ground card. Click on the mechanic. The ground card is now connected. The green avail light has appeared, which means external power is plugged in. Its voltage and frequency are normal, and it is ready for use. Switch the external power on. When the cyan on light is illuminated, the ground card is supplying the aircraft. The ECAM electrical pages have been called for you. Usually, only one ECAM electrical page can be displayed at a time on the lower ECAM. For training purposes, we will show both at the same time. We can confirm that external power A is supplying normal voltage and frequency because the parameters shown on ECAM are green. By following the green lines on the ECAM pages, you can see that the external power is supplying all the electrical system. If external power B was also connected, it would supply the left side of the network and external power A the right side. Notice that as the engines are not running, the indications of the associated generators and engine numbers are in amber, and fault is illuminated in amber on the generator push-button switch. You can see the green arrows which indicate that the DC bat bus is charging batteries 1 and 2. Notice also that the DC APU bus is charging the APU battery. Both batteries are now charging from the DC bat bus. During this time, you can continue with your cockpit preparation. The average charging cycle is approximately 20 minutes. As you can see, all batteries have now disconnected from the DC bus. There are no green lines connecting the batteries to their corresponding DC bus. The battery voltages are normally checked using the bat selector with the batteries switched off. Switch bat 1 off. You can check on the panel that the voltage of battery 1 is normal. Notice the white off indication on the ECAM page and the off light illuminated in bat 1 push-button switch. Switch bat 2 off. You can check on the panel that the voltage of battery 2 is normal. Switch APU bat off. You can check on the panel that the voltage of APU battery is normal. As you can see, the 3 batteries now have voltages above 25.5 volts. The battery charging cycle is completed. we need to switch the batteries back on. We will do this for you. The 3 batteries are now available. After the battery check, the standard operating procedure recommends that the battery selector should remain in the APU position to avoid the discharge of bat 1 or 2. It is now time to start the APU and disconnect external power. We will start the APU for you. You can see on the AC ECAM page that the APU generator parameters are now displayed. Notice that the APU generator has automatically taken over supplying the left part of the electrical network. This is because APU generator has priority over external power A for this side, and over external power B if connected. When deselecting external power A, the APU generator takes over. Switch the external power off. A green line has appeared connecting the APU generator to the right side of the network. We can see that the external power is still available. However, we no longer need it, so it can be unplugged by the ground personnel. Click on the mechanic. The avail light goes off, and the external power indications on the ECAM have disappeared. The external power source is disconnected. Let's look for a moment at the outside of the aircraft to see the only item associated with the electrical system on the walk-around. You should check that the ground electrical power door is closed, if not required. You have finished normal operation A. We will continue with normal operation B. We are back in the cockpit, and it is time to start the engines. Usually, when we start the engines, the ECAM engine page is displayed. However, for training purposes only, we will keep the ECAM electrical pages displayed throughout the flight. Normally, only one ECAM electrical page can be displayed at a time on the lower ECAM. For training purposes, we will show both at the same time. The electrical system is designed so that each engine generator will automatically come online and power its respective bus. We will start engine 1 first. Click on engine 1. The engine is running as indicated by its identification numbers in white. Notice the generator automatically supplies the left side of the electrical system, leaving the APU to power the right side. Also notice that the fault light on the generator 1 push-button switch has disappeared. Click on engine 2. Engine 2 generator takes over from the APU to supply the right-hand side of the system. The fault light on the generator 2 push-button switch has also disappeared. The APU is no longer connected to the network, and the APU generator is now showing 0% load. Once both engines are running, the APU can be switched off. Switch off the APU. The electrical system is now in the normal configuration for taxi, takeoff and landing. In a normal flight, no further change occurs to the electrical configuration up to the APU start on taxiing in. We are in cruise. Notice that the indications external A and external B are not displayed in flight. We have just landed and are taxiing to the gate. We will start the APU for you. The APU is now available and is standing by to take over from the engine-driven generators when the engines are shut down. Both engines can now be shut down. Click on either engine. Both engines are stopped. The APU generator is back online and has automatically taken over supplying the entire electrical system. For training purposes, we will assume that the aircraft is to be completely shut down. So you have to request an external power source. Click on the mechanic. The avail light on the panel and the external power indications on the ECAM have appeared, indicating that the external power source is plugged in and available. Select External Power On. The on light comes on in the external power push-button switch, and the green lines to AC bus 2 indicate that external power has taken over from the APU for the right side of the network. We can now shut down the APU. Switch off the APU. The external power can now be switched off when convenient. Switch the external power off. We are back to a normal display configuration. When on batteries, only the upper screen remains active. Switch APU bat off. Please carry on. Switch bat 1 off. The upper screen is now off. Switch bat 2 off. All lights on the overhead panel have disappeared, except the avail light, which is receiving power from the external cart. The battery voltage indications are LCDs and are wired directly to the batteries, so that they are always displayed. The aircraft is now considered to be electrically shut down. This completes the normal operation modules. We will start with an IDG oil low pressure fault. Let's assume you are the pilot non-flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Observe the IDG low pressure in amber on the ECAM electrical page. Observe IDG1 fault light illuminated on the electrical panel. These indications mean that the oil pressure in IDG1 is not sufficient. We can see from the blue action line that we are required to disconnect the IDG from the engine. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. The push-button switch guard is up. You can now disconnect IDG 1. Continue ECAM action. Caution. Press IDG push-button switch until generator fault light comes on, but not more than 3 seconds to avoid damage to the disengaged solenoid. As you can see, generator 2 has automatically taken over, and it is now supplying the entire electrical network. On the ECAM electrical page, an amber disconnect has replaced the previous low pressure indication, meaning that IDG1 is now disconnected. The IDG number is in white to indicate that engine 1 is still running. Let's look at generator 1 indications for a moment. Generator in amber means generator 1 has abnormal parameters. 1 in white means engine 1 is still running. 0% load in green means that the load is still within the normal range. 0 volts in amber means that the voltage is outside the normal range. And 0 Hz in amber means that no frequency is sensed. Fault amber illuminated in the generator 1 push-button switch means generator 1 is not supplying the network. The white indication at the bottom of the page indicates that some of the galleys have automatically been shed. After review and confirmation from the pilot flying, clear electrical. The status page is displayed for review. A green message advises us that we are limited to Cat 3 single only. You can see in the inoperative system column that generator 1 and some of the galleys are now inoperative. After review and confirmation from the pilot flying, clear status. ECAM action completed. We will now review some indications we did not have the opportunity to see when performing the previous procedure. In case of IDG oil overheat, notice the amber IDG oil outlet temperature. Note that the rise indication shows a difference in temperature between the IDG oil inlet and outlet. In case of an overload detection in the electrical system, and if the automatic shedding has not occurred, an ECAM procedure is triggered and a fault light comes on the galley push-button switch. The galley push-button switch authorizes the crew to shed all galleys. Switch the galleys off. The generator 2 parameters are now back to normal. The white galley shed message indicates the new status of the galleys. The commercial push-button switch enables the crew to switch off commercial equipment in the cabin, e.g. galleys, passenger entertainment system, lavatory and cabin lights. The commercial off message appears in white at the bottom of the page if the commercial equipment is manually switched off or automatically shed in case of failure. Note that this message has priority over the other galley messages. You have finished the first abnormal. Let's carry on with the second one. In this module, we will look at an AC essential bus fault. Assume we are in flight with no previous faults. Autopilot 1 and autothrust are engaged. Let's first review the ECAM electrical AC page. Call the ECAM electrical AC page. AC essential bus is normally supplying different systems, and in particular the pilot screens. In case of failure, it may be possible to manually recover the AC essential bus using the AC essential feed push-button switch. We will demonstrate this point. Click on the forward arrow to activate the failure. As you notice, the first consequence is that the captain's PFD, ND and the upper ECAM are blank. The SOP recommend in such a case that the first officer should fly the aircraft while the captain does the ECAM action. The engine warning display is now displayed on the lower ECAM. We can see that the AC essential bus fault has led to AC essential bus shed failures. For training purposes, let's manually call the ECAM electrical AC page to study it. Call the ECAM electrical AC page. The ECAM electrical AC page is displayed on the lower ECAM as long as you maintain the electrical AC key pressed down. Notice the amber indications. The AC essential bus, the AC essential bus shed, and the essential TR are no longer supplied. Call the ECAM electrical DC page. As for the AC page, the ECAM electrical DC page is displayed on the lower ECAM as long as you maintain its associated key down. Notice the amber essential TR parameters, meaning that it is no longer supplied, and the line connecting the DC BAT bus to the DC essential bus. This is due to an automatic reconfiguration of the electrical system to maintain the power supply to the DC essential bus. We have released the electrical DC key for you, and the engine warning display is automatically displayed on the lower ECAM. The first line in the procedure shows us how to recover the AC essential bus. You will have to switch the feed of AC essential bus from AC bus 1 to AC bus 2. The pilot flying will ask you to perform the ECAM actions. Notice on the electrical panel the fault light on the AC essential feed push-button switch. Perform ECAM action. The recovery has been successful, and the screens are recovered after a few seconds. We are back to a normal situation, with the engine warning display back on the upper ECAM, and the ECAM cruise page automatically displayed on the lower ECAM. The other steps of the procedure have disappeared with the recovery of the AC essential bus. ECAM actions completed. We have recalled the ECAM electrical AC page for you. You can see on the ECAM electrical AC page that the AC essential bus is now recovered. For that, AC bus 2 is now supplying it. On the electrical panel, the fault light on the AC essential feed push-button switch has been replaced by a white alternate light. This means that the AC essential bus is supplied by its alternate source, AC bus 2. The electrical AC key has been released for you. The ECAM cruise page is displayed again. We will now review an automatic electrical network reconfiguration we did not have the opportunity to see when performing the previous procedure. In case of AC bus 1 fault, there is an automatic reconfiguration leading to supply the AC essential bus and the essential TR from the AC bus 2. TR1 is replaced by TR2. It supplies DC bus 2, which in turn supplies DC bus 1 via DC BAT bus. No manual action from the crew is required. You already know that the electrical system is able to reconfigure itself depending on the availability of the various power sources, but also in case of failure. All these reconfigurations are performed via contactors, which are controlled by two computers called Electrical Contactor Management Units, ECMU. Each ECMU controls its own side. ECMU 1 on the left, ECMU 2 on the right. We will now study what happens in case of failure of ECMU 1. Let's assume you are the pilot non-flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Notice that if the system page is automatically called, there is no failure shown. This is due to the fact that if the ECMU1 associated contactor control is lost, these contactors remain closed, self-held, provided the generator push-button switch is on. In consequence, the AC part of the system keeps the same configuration. For training purposes, we will call the ECAM electrical DC page. Call ECAM electrical DC page. Notice the new configuration of the DC part. The DC BAT bus power supply has been automatically switched to DC bus 2. Release the electrical DC key. As no corrective action is required, after review and confirmation from the pilot flying, clear electrical. The status page is displayed for review. A cyan message advises us to keep generator 1 on. Notice the list of affected systems. After review and confirmation from the pilot flying, clear the status page. ECAM action completed. You have seen an ECMU1 fault. We will now study an APU-TR circuit breakers tripped. You are in flight. Everything is correct. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Note that the ECAM circuit breakers page has to be called manually. Call ECAM circuit breakers page. On the circuit breakers page, you can read that the APU-TR circuit breakers 3PU3 is tripped on panel 5000 VU. Go back to cruise page. In order to perform the ECAM action, you have to clear the first line. Clear electrical. The system page is automatically displayed. Notice the APU-TR amber indications. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. Switching off the APU battery will enable you to save the APU battery power, should an APU start be necessary later on. After review and confirmation from the pilot flying, clear electrical. The status page is displayed for review. A cyan message advises us that, for an APU start, we have to switch the APU bat back on. Also notice the APU-TR indication in the Inoperative System column. After review and confirmation from the pilot flying, clear the status page. ECAM action completed. We will now study the electrical emergency configuration. We will demonstrate the case when the system is powered from the RAT. For that, we will assume that the green hydraulic circuit is already faulty. Note, if the green hydraulic system, which actuates the emergency generator, was supplied by an engine-driven pump instead of the RAT, more electrical power would have been available. This limited amount of power will lead to the shedding of some equipment or electrical buses. As there are a lot of events which happen at the same time in the aircraft, we will present them in a sequential order. Let's assume we are in flight and no previous faults have occurred. Click on the forward arrow to activate the failure. As you can see, the first consequence is that the power supply for the first officer's PFD and ND, the captain's ND, and the lower ECAM is lost. The standard operating procedure recommends, in such a case, that the captain flies the aircraft while the first officer does the ECAM action. Observe that on the emergency electrical power panel, the red Emer-Gen fault light is on, meaning that the emergency generator is not yet online. Observe that the Emer-Gen light has disappeared. The emergency generator is now running and supplying the network. Note, the captain's ND would have been restored if the green hydraulic system was supplied by an engine-driven pump instead of the rat. Read the title of the failure. The red Emer config title means that you are in an electrical emergency configuration. The red message, Land ASAP, recommends to land at the nearest suitable airport as soon as possible. The pilot flying will ask you to perform the ECAM actions. You will try to reset the generators. Here, this will be done for you. The reset of the generators has not been successful. Before continuing with the procedure, let's look at how to access an ECAM page when the lower ECAM is not available. An ECAM page can be called up on the upper ECAM by pressing and holding its associated push-button switch on the ECAM control panel. Call the ECAM Electrical AC page. The page is displayed on the upper ECAM as long as the associated key is maintained pressed. Notice that the Emer Gen box and its parameters have appeared. The emergency generator supplies the AC Essential bus and the Essential TR. Note also that the AC Essential Shed bus is shed due to the limited power of the rat. The white indication at the bottom of the page means that the commercial equipment is also shed. To see the DC part, you have to call the ECAM Electrical DC page. Call the ECAM Electrical DC page. Notice the emergency generator supplying the Essential TR, which in turn supplies the DC Essential bus. The DC Essential bus shed is also shed due to the limited power of the rat. As soon as the key is released, the engine warning display is back on the upper display. As the previous reset of the generators was not successful, we will carry on with the procedure. Continue ECAM action. The bus tie push-button switch in the off position segregates the two sides of the system. By doing this, a short circuit can be isolated and might give you the possibility to reset one generator. The procedure asks you to try to reset the generators again. Here, this will be done for you. Again, the reset of the generators has not been successful. As the next steps concern other systems, we will stop here and study the indications on the right side of the engine warning display. Notice the green arrow. It indicates that other failure messages and their associated procedures are stacked after the Emer config one. The list of affected systems is displayed on the right engine warning display memo. We will now assume that all the procedures have been reviewed. As you clear the last one, memo messages appear on the engine warning display. The green Emer Gen memo message indicates that the emergency generator is running and supplying the system. The green rat out appears when the rat is not fully stowed. We will now jump to the approach phase. a status page has been called for you. You can read on the approach procedure that you will have to switch the land recovery push-button switch on. This will allow you to recover the necessary systems for the approach and the landing, e.g. ILS-1, slats flaps channel 1, LGCIU-1 and BSCU-1 will be recovered. Switch on land recovery. The ECAM electrical AC page has been called for you. For training purposes, the ECAM electrical DC is also shown. The land recovery AC and DC buses are now connected, which is shown by green indications on both ECAM electrical pages. As the system is powered by the RAT, at slats extension, the emergency generator will be inhibited and the supply will be automatically transferred to the batteries. Set flap 1. For training purposes, both ECAM pages are shown. Notice the amber indications for the essential TR, which is no longer supplied by the emergency generator. The DC essential bus is supplied from both batteries as indicated by the amber arrows. As the battery discharge currents are high, the current indications are displayed in amber. Observe that the Emergen title has turned amber, while the static inverter parameters are now shown. The AC essential bus is supplied from the DC essential bus via the static inverter. On the ground at low speed, the DC BAT bus is automatically connected to the batteries. For training purposes, both ECAM electrical pages are shown. We will now review some indications we did not have the opportunity to see when performing the previous procedures. As a result of a severe electrical failure and a lack of hydraulic power to actuate the emergency generator, the RAT is normally automatically deployed. During the RAT extension, the electrical system is powered from the batteries. The approximate flight time on batteries is 30 minutes. Let's see what happens if the RAT fails to deploy automatically. If the emergency generator fails to start, a specific line appears in the emergency electrical procedure telling you to manually extend the RAT on the emergency electrical power panel. Press the manual on push-button switch. The guard is up. You now have to extend the RAT. Extend the RAT. The Emergen fault light extinguishes as soon as the emergency generator is supplying the system. If the emergency generator is not working after the RAT extension, the red fault light stays illuminated on the Emergen indicator. This failure causes the aircraft to be powered only from the batteries. For training purposes, both ECAM electrical pages are shown.